Good afternoon and welcome to this week's Tim's Tech Blog here at Venom Motorsports. And what we're going to look at today and spend a little bit of time reviewing with you is how to do some basic troubleshooting with an electric meter. Now, when you look at electric meters, they come in all sorts of different shapes and sizes. This particular one is made by the good folk at Amprobe, and you can pick up any basic cheap electrical meter you want. We're concerned primarily with using it to test using the unit ohm, and we're going to discuss that in a minute, and also looking at voltage. So again, we're going to have a look at that and review. So when you're looking to choose a multimeter, what are you looking for? Well, for most of you, it's just going to be price. You can pick up a really good multimeter these days for less than $25. And again, you're looking for one that will read in the unit ohm for resistance and in the unit DC voltage that you see here. Now you'll notice for DC voltage there's a broken dashed line, and all of our bikes, which are fossil fueled powered, that is gas powered, will be using a 12 volt DC system. So again, 12 volts DC. This side is going to be used for measuring current flow and voltage for alternating current. And your bike does not produce alternating current in its running systems. It produces 12 volts DC. So when we have a look at your bike, a few points to note. The first is, well, how do you describe and talk about electricity? Typically, we like to use a term called ladder diagram. And a ladder diagram looks like a ladder. So on one side of the ladder, we're going to put a positive terminal. And on the negative side of the ladder, we're going to place a negative terminal. Between these two terminals, you should read a 12 volt DC potential. That is, if you were to connect the red probe from your multimeter to this side of the battery, the positive side of the battery, and the black negative probe over here to the negative side of the battery, you would read 12 volts DC on your electric meter. Now, in order to do that, you'd firstly have to ensure that the electric meter was set to read for voltage, DC, and in this case, you achieve that by moving it to the 12 volt DC indicator on the meter. Now, you'll note it doesn't say a 12 volt specific range, but it gives you up to 20 volts. So you set it for the up to 20 volts DC range, take a reading. And again, what would the reading be? The reading would be 12 volts DC with the red probe, positive probe attached to the positive terminal on your battery, and over here to the negative side of the battery, 12 volts DC. That's the potential difference voltage that you have in your system. So what's the purpose of the voltage? Voltage is the push. It's the push of electrical charge through the system. Well, what's the next concern? If we have a look at this, we can use a multimeter to quickly and easily check a variety of things. A multimeter is extremely handy if you set it to read resistance on the 200 ohm, and ohm is the unit of resistance in electrical systems. So the unit ohm is equal to resistance. And when you're measuring resistance, typically we're going to be measuring resistance across devices like a fuse. And this is a good indication or example of a fuse right here. This is called a cartridge fuse. And when you trace out the power supply for your bike, you're going to notice that there's two wires coming from the positive side that are red in color. One is very thick and the other is quite thin. The thick positive charge will go directly down to your starting motor. The thin wire will feed into one end of this cartridge and then come out the other. So this cartridge is a fuse, and it's called a cartridge fuse because it looks like a cartridge. And it is rated at 15 amperes and is able to deal with 250 volts. Now, it'll never see 250 volts, but this is its overall power rating. So if you ever pop this fuse, you need to have a fuse that is the exact same size, physically the exact same size, and is capable of dealing with 15 amps and 250 volts. So if you go and take this into your local home hardware or True Value Hardware, Canadian Tire, this sort of thing, just give them that rating, bring the fuse in if possible to make sure you get the correct physical size, and they'll be able to give you a replacement. Now, the fuses themselves are typically not that expensive. So this type of fuse, you should be able to pick one up for maybe $2. So again, you're going to bring the fuse in. I need one this physical size, rated at 15 amps, 250 volts. Now, if this fuse had actually popped, you'll notice that there's a filament inside. The filament here is still in excellent shape, nice and shiny, and you can see that it runs from one end of the fuse to the other. If this fuse had burnt, you'd see some blackish discoloration, and the fusible link inside would actually have separated. It would have melted to a degree. And when you were checking it with your meter, you would not be able to measure it for continuity. So continuity in electrical work is a very important concept. It means that you have a continuous point of conduction, or a complete path. So with electric meters, right now you'll notice that my probe leads are apart and the meter reads infinite resistance, meaning that there is no completed path of flow. If I touch the two terminal leads together, the meter immediately jumps down to 0, meaning that there is basically no resistance in this circuit. It's a complete circuit and easily allows current flow to conduct. Now, if I was going to test a fuse and the fuse was good, I would put one end of the probe here, one end of the probe on this end, touch those 2 points together, and again the fuse would read 0 ohms of resistance. 0 ohms meaning that the fuse is good. So you can use your multimeter to check for resistance and determine the state or functionality of a fuse, but you can also use that exact same principle to check and see if a switch works. So when you have a look at electrical circuits, and let's just pick one on your bike. Your bike is going to have some sort of switching mechanism which will control the power supply to a lamp. So this switching mechanism, the light switch, is going to have a red positive terminal from the positive side of the circuit, through the lamp switch, over to the lamp, and then going from ground to complete the circuit, from this side of the lamp over to the ground on the bike. Now when we talk about the ground on the bike, very important note, the ground is the negative side of the battery. It is also the complete frame of the bike. You see, all of the bikes take the battery and they run a ground directly from the battery to the frame of the bike. So what you'd see on the bike then would be a red wire going into the switch, a red wire perhaps coming out of the switch going to the lamp, and then a green wire running from the lamp to the frame of the bike. If you wanted to test and see if indeed this switch was working, the first thing you have to do is to disconnect one of the battery leads. The reason for this is you cannot check resistance in a circuit and still have the power connected. So take the negative terminal off the battery or take the positive, but take off one of them. And I recommend taking off the positive. Take the positive terminal off. You're now 100% certain that there's no potential difference in the circuit and you're ready to check. So again, what would you check for? You're checking for continuity. So if the switch is open, as it is drawn right now, and you take your two probes and place one probe at each end of the switch, you should have infinite resistance. And again, if you're using a digital multimeter, it will read this funny looking 1, which is infinite resistance. If you close the switch, so you now close the lamp, if you had power going to the circuit, the lamp would indeed light up. Now, at this point, if you close the switch physically, this is what you should see on your meter. Your meter should react, and you should now have almost no resistance. So again, you can check any switch on your bike using this same test. Ensure firstly that you disconnect the power supply, so the terminal on the positive side of your battery is removed. Then go ahead, check for resistance levels, moving the switch from the on and off position. So what sort of switching devices do you have on your bike? Well, you've got a switch for your lamp. What else do you have? What about your ignition? And your ignition switch is, again, it's just a switch. And your ignition switch feeds into a device called an ignition relay. And a relay, again, is just a fancy switch. But what makes this switch interesting is the relay is going to send some power down to your starting motor, but it's only going to send power down to your starting motor when the starting switch is depressed. So you depress the starting switch and make this connection. This then allows power to go into the starting relay. The relay then allows power to flow to the starting motor and completes the circuit to the starting motor so that your bike will indeed roll over. So the question then is, well, why do we have a starting relay? If you have a look at the wire that feeds the power to the starting motor, it's quite large, meaning that the gauge is quite large. If you have a look at the starting switch, the wire feeding into the switch and away from the switch is quite thin. So you see, by using relays strategically in a bike, we don't have to use super thick wire all over the bike. This is why it's done. So switching, you'll have things like a switch for your light, a switch for your starting relay. What about your horn? My horn doesn't work. How do I check that? You get in the picture? If this is your horn is exactly the same. It's just a switch and a horn. So you can check the switch mechanism to ensure that it is indeed functional, again using the same processes that we learned up here, right? So check it out with your meter, and you're going to check for continuity to see if you do indeed have a switch that's functional or not. And again, if you press the switch, and again there's no power in the circuit, right? So the positive terminal on the battery's out. You have your meter set to measure in resistance the unit ohm. You press the switch, you should have continuity. And if you have continuity in the circuit, that is, the horn switch is indeed working properly, your resistance levels should be extremely low. If you close the horn switch contacts and the resistance level looks like this, that tells you, oops, my horn switch is no longer any good, I have to replace it. The exact same is true as if, again, you were having a look at the starting switch on your bike. If you close this switch and your resistance is extremely high, you've got a problem. It means that this switch has failed. And again, this is just a basic testing procedure using a multimeter to check for resistance. Works extremely well and is very handy. So what else can you do with this knowledge? You've learned about ladder diagrams. You know that you have a 12 volt DC potential between the positive and the negative side. If we spend another minute on this diagram, there might be something else we can get from it. So in electricity, people like to use terms like series and parallel. And well, what does that mean? Series, like a switch, means that the electrical charge and all of the electrical charge must flow through it. It means only one path of flow. So in this case, the switch is connected in series with the load. In this case, the switch is connected in series with the load. In this case, the switch is connected in series with the load. So you might say that all switches are always going to be connected in series, that is, controlling the flow of electrons to the load. What's interesting in electrical is that you can have a variety of different loads being controlled from one switch. So in this case, we would say this switch is in series, controlling all of these loads, which are connected in parallel. Next question is, well, why do you have things in series and why in parallel? We have things in series to control the current flow to the devices. The devices, the motors, these sort of things that are going to do the actual work for us, are always connected in parallel, parallel, parallel to ensure that each one of these loads receives 12 volts. That's how your bike works. That's how your home works. If you have a look at your house, all of the electrical circuits that power things up are connected in parallel. The switches are connected in series. So if this was your home now instead of your bike, you'd have 120 volts, alternating current. You'd have a switch, a light switch, controlling the electrical energy to a light. It's the exact same process. So keep that in mind. This can really help you with your troubleshooting skills. A little bit of electrical goes a long way. Now, if you were playing with an electrical circuit, and let's say for fun, you were playing with this switch, and you're pretty sure that the switch was the problem. So you've checked for continuity, and you're just about 100% sure that the switch is the problem, but before you go out and spend any money, you're wondering if there's anything else you can do. Well, the other anything else you can do is pick up a device that looks like this. This is called a jumper cable. And this little jumper line, if you place one line or one alligator clip on this side of the switch and one alligator clip on that side of the switch, you now have effectively bypassed the switch. And if you do this and all of a sudden the light comes on and it wouldn't come on before because the system wasn't working, that again tells you the switch is no good. So you've got some options here. So a little bit of basic electrical for you today. And again, highly encourage you to get out there, buy yourself a nice little meter. There's all kinds of super tutorials on YouTube these days, just amazing for electricity. Highly encourage you to develop some electrical troubleshooting skills. Very handy when you own a bike. Until next week, thank you for watching. Please take a moment and subscribe to my YouTube videos. Have a great day. Enjoy the ride, my friends. Bye-bye.